Good day, everyone. Today we are going to discuss the examples of uniform distribution, binomial, negative binomial, hypergeometric, geometric, Poisson, and normal distribution. Let's talk first the examples of uniform distribution. Example 1. Suppose a spinner is rotated over the tray that consists of 4 individual compartments. Each compartment is colored different from others. So the probability that the spinner after spinning would point towards any of 4 colored compartments is equal to 0.25 or 1/4. So when we look at the picture there and consider this spinner is rotated, then the probability of getting blue is 1/4, same with green 1/4, purple and pink is same 1/4. Tanan sila na ay equal chance nga mapilian bu sa example siya sa uniform distribution. Another example of uniform distribution is this. The probability of a person winning a lucky draw contest is equal for every other person participating in the contest. So, tanan nga ni appeal sa contest, tanan sila kay na ay equal chance of winning. For example, na ay 500 ka tao nga ni appeal sa contest. So, ang probability nga ni daog siya kay 1/500. Kay isa ra ang mudaog out of 500 ka ni appeal. So, same sa kauban niya. Anang nga ni appeal. Ang probability po ng chance nga makadaog siya kay 1/500. Sa example ni siya sa uniform probability distribution. So, next is the example of binomial distribution. Example 1. A box of candies has many different colors in it. There is a 15% chance of getting a pink candy. So, what is the probability that exactly 4 candies in a box are pink out of 10? So, solution. So, ang given nato diri kay probability of x equals to 4. Kay mao man atong pangitaon. Then, n equals to 10. Kay na ay 10 ka pink candies. Then, p equals to 0.15. Kay mao ang probability of success nga na ay 15% chance nga makakuha taog pink nga candies. Then, ang q kay 0.85 kay ang probability of failure. Nga, para makuha pod ang Q, kay minusan nato ang 1 o P. So, ang X dahil nato kay equals to 4, kay ang kay na 4 candies nga atong pangitaon. So, ato ni siya i-solve gamit atong binomial distribution formula. So, probability of x equals to x equals to n chooses x times p raised to x times q raised to n minus x. So, ang probability of x equals to 4 equals to 10 chooses 4 times 0.15 raised to 4 times 0.85 raised to 6 is equal to 0.04009. So, na ay 0.04009 na probability nga makakuha taog exactly 4 pink candies out of 10. Another example for binomial distribution. A factory produces light bulb and historically 10% of the bulb are defective. If a sample of 8 bulbs is randomly selected, what is the probability that exactly 2 of them are defective? So, solution. Itong given kay n equals 8, kay 8 ang selecting light bulbs. P is 10%, equals to 0.1 kay ang probability of defective valves. Then x equals to 2 kay mo ang defective valves. So by using the binomial probability formula, the probability of 2 equals 8 chooses 2 times 0.1 raised to 2 times 0.9 raised to 6 equals to 0.149. So the probability that exactly 2 out of 8 random selected valves are defective is 0.49. Next is the example of negative binomial distribution. Example 1. Jem is writing an exam with multiple choice questions, and his probability of attempting the questions with the right answer is 60%. What is the probability that Jem gives the third correct answer for the fifth attempt question? Solution. Probability of success of P of S equals 60% equals 0.6. Then probability of failure equals 40% equals 0.4. Given that X equals 5 and R equals 3 and P equals 0.6, which is the probability of success, 1 minus P equals 0.4, which is the probability of failure. We solve it using the negative binomial formula equals x minus 1 chooses r minus 1 times p raised to r times 1 minus p raised to x minus r equals 5 minus 1 chooses 3 minus 1 times 0.6 raised to 3 times 0.4 raised to 2 equals 6 times 0.216 times 0.16 equals 0.020736. Therefore, the probability of Jim giving the third correct answer for his fifth attempt question is 0.0207. Another example for negative binomial distribution. An oil company conducts a geological study that indicates the exploratory oil well should have a 20% chance of striking oil. What is the probability that the third strike comes on the seventh well drilled? Solution. Given are probability of x equals 7, mao na siya atong ginapangitaon. Then p equals 0.20 since na ay 20% chance of striking oil ug mausad ang probability of success. Then 1 minus p or the probability of failure equals to 0.80, x equals to 7 and r equals to 3. Then use the negative binomial formula, the probability of x equal to 7 equals 7 minus 1 chooses 3 minus 1 times 0.20 raised to 3 times 1 minus 0.20 raised to 7 minus 3 equals 6 chooses 2 times 0.20 raised to 3 times 0.80 raised to 4 equals 0.0491. Therefore, there are 0.0491 chance that the third strike comes on the seventh well drilled. Next is the example of hypergeomtric distribution. Example 1. An ordinary deck of playing cards from where 6 cards are drawn randomly without replacement. Determine the probability of drawing exactly 4 red suit cards, example diamond or hearts. Solution. Given that n equals 52, kay na ay 52 cards as sa ordinary playing deck. Then n equals 6 sa number of cards are drawn. R equals 20 26 kay naay tag 13 red cards sa diamond ug hearts, then x equals 4 so kay na number of reds to be considered as a successful in sample drawn. By using the hypergeometric formula, probability of x equals r chooses x times n minus r chooses n minus x divide by n chooses n. So, probability of x equals to 4 equals 26 chooses 4 times 52 minus 26 chooses 6 minus 4 divide by 52 chooses 6. Then solve this using the combination 26 chooses 4 or 26 combination of 4 times 26 combination of 2 divided by 52 combination of 6 equals 0.2387. Therefore, there is a 0.2387 probability of drawing exactly 4 red cards while drawing 6 random cards from an ordinary deck. Another example for hypergeometric. The jar contains 5 red candies and 10 non-red candies for a total of 15 candies. We'll randomly draw 5 candies from the jar. Let's calculate our chances of getting 2 red candies in our 5 draws. Solution. So the given are n equals 15, which is the total number of candies. N equals 5 since jar contains 5 red candies. R equals 5 since we have 5 numbers of draws. X equals 2, which is the chances of getting red cards. By using the hypergeometric formula, probability of x equals to 2 equals 5 chooses 2 times 15 minus 5 chooses 5 minus 2 divided by 15 chooses 5. Then we will calculate it using the combination. So 5 combination of 2 times 10 combination of 3 divided by 15 combination of 5 equals 0.3996. Therefore, the probability of drawing 2 red candies in our 5 random draws from the jar is 0.3996. Here are the examples of geometric distribution. Example 1. A representative from the National Football League's marketing division randomly selects people on the random street in Kansas City, Kansas, until he finds a person who attended the last home football game. Let P the probability that he succeeds in finding such a person equal to 0.20, and let X denote the number of people he selects until he finds the first success. What is the probability that the marketing representative must select 4 people before he finds one who attend the last home football game? Solution. To find the probability of x equals to 4, we need to substitute the formula of geometric distribution, which is P of x equals P times Q raised to x minus 1, which is P equals 0.20 and Q equals 0.80, where P is the probability of success and Q is the probability of failure. Then probability of x equals to 4 equals 0.20 times 0.80 raised to 4 minus 1, equals 0.20 times 0.80 raised to 3 equals 0.1024. Therefore, the probability that the marketing representative must select 4 people before he finds one who attend the last home football game is 0.1024. To find the mean and variance of the example number 1, here's are the formula of the mean. Mean equals the mu equals expected value of x equals 1 over p, where p is the probability of success. Then 1 minus 0.2, which is 0.2 is the probability of success in our first example. Then 1 divide by 0.20 equals 5. Then to find the variance using the formula of the variance of sigma squared equals variance of x equals 1 minus p of divide by p, where p is still the probability of success. Then equals 0.80 divided 0.20 raised to 2 equals 20. Another example for geometric distribution. When looking at a person's eye color, it turns out that only 2% of the people in the world have green eye. Note, not to be confused with hazel-colored eyes. Randomly select people and look their eye color. What is the probability that you get someone with green eyes on the 5th person? Solution. To find the probability of x equals to 5, substitute the formula of geometric distribution. Then, probability of x equals to 5 is equals to 0.2 times 0.98 raised to 4 equals 0.0184. Therefore, the probability that you get someone with green eye on the 5th person is 0.0184. Next is the example of Poisson distribution. Example 1. In a cafe, the customer arrives at a mean rate of 2 per minute. Find the probability of arrival of 5 customers in 1 minute using the Poisson distribution formula. Solution. Given that lambda equals to 2, which is the mean, and x equals to 5. Using the Poisson distribution formula, probability of x equals to e raised to negative lambda times lambda raised to x divided by x factorial, where e is approximately 2.71828. Probability of x equals to 5 equals to e raised to negative 2 times 2 raised to 5 divided by 5 factorial is equals to 0.036. Therefore, the probability of arrival of 5 customers in 1 minute is 0.036. Another example for Poisson distribution. A call center receives an average of 6 calls per hour. What is the probability that they will receive exactly 4 calls in a given hour? Solution. Given that lambda equals to 6 and x equals to 4 and a is approximately 2.71828. Using the Poisson distribution formula, probability of x equals to 4 equals to e raised to negative 6 times 6 raised to 4 divided by 4 factorial is equal to 0.1338. Therefore, the probability that they will receive exactly 4 calls in a given hour is 0.1338. And lastly, the example of normal distribution. Example 1. You collect SAT score from the student in the new test preparation course. The data follows a normal distribution with a mean score M of 1,150 and standard deviation or SD of 150. You want to find the probability that SAT score in your sample exceed 1,380. Solution. Given the mean equals 1,150, standard deviation of 150, and x equals to 1,380. First, we need to find the value of z using the formula of z equals x minus mu, or the mean, divided by sigma, or the variance. Then, z equals 1,380 minus 1,150 divided by 150. Then, z equals to 1.53. Now, we will find this z equals 1.53 in our z table. Then, here is the value of 1.53. 0.93699. Using the z table, we find that for z score of 1.53, the value is 0.9369. Since we will find the probability that SAT score in the samples exceed 1,380, then probability of P is greater than 1,380 is equal to 1 minus 0.93699 is equal to 0.063. Therefore, the probability that SAT score in your sample exceed 1,380 is 0.063. Another example for normal distribution. The daily water usage per person in a town is normally distributed with a mean of 20 gallon and a standard deviation of 5 gallon. What is the probability that the person from the town selected at random will use a fewer than 18 gallon per day? Solution. Given a mean equals 20, standard deviation of 5, and x equals 18. First, we will find the value of z using the formula, which is z equals x minus mean divided by variance. Then, probability of x is lesser than 18 equals to probability of z lesser than 18 minus 20 divided by 5 equals the probability of z is lesser than negative 0.40. Then, it equals to 0.34458. Now, we will check it in z table. Then, z is equal to negative 0.40 is equal to 0.34458. Therefore, the probability that the person from the town selected at random will use fewer than 18 gallon per day per person per day is 0.34458. The references. That's all. Thank you for listening. Have a great day, everyone.